So for nuclear, we know specifically where the spent fuel, also known as nuclear waste, is located. We know every dry casket and the location of each of one of those caskets, right? And it's perfectly safe to go around them, to take pictures with them, to walk around them, it's perfectly safe. What about the oil and gas industry waste? You just need to take a deep breath and that's it. They don't account for all of the emissions that they do while producing electricity using oil and gas, right?
It's just one small part of the conversation. And yes, we have more interesting topics covered, so stay tuned. Hello and welcome back to yet another episode of the Mission Shunya podcast, where we bring you stories at the intersection of sustainability, technology, and the energy transition. If you have been following the nuclear energy series, you have already heard from voices across the spectrum, from researchers and fusion startup founders to institutional leaders helping shape global nuclear policy. Each episode has explored a different lens on nuclear: science, strategy, perception, and potential. But what underpins all of this, the very foundation for safe and reliable nuclear operations, is risk. Not just perceived risk, but quantified, modeled, and continuously reassessed risk. That's where today's episode comes in. We are talking about Probabilistic Risk Assessment, or PRA, a tool central to nuclear safety and design decisions. But what exactly is PRA? How does it differ from traditional risk models? And why should engineers, regulators, and the general public care about it? To discuss this in detail and a lot more, let us bring in our guest, who is...
Hi everyone, I'm Jenifer Avellaneda, and I currently work as a Probabilistic Risk Assessment Senior Engineer at Westinghouse Electric Company. I'm based in Texas, and I support several U.S. nuclear power plants, including Comanche Peak.
So, you are one of the very few practitioners that I have on this series around nuclear energy on the podcast. So, to begin, let's look at the work that you do. What does a PRA engineer actually do? And how did you actually end up as a PRA engineer?
Sure, that's actually a very exciting question. So I currently work, as you said, as a Probabilistic Risk Assessment Engineer, or for shortening that, it's a PRA Senior Engineer at the Westinghouse Electric Company. I am currently based in Texas, and I give support to several U.S. nuclear power plants, including Comanche Peak, which is located here at the north of Texas. So as for what is PRA, basically my role involves evaluating the potential risk associated with operating a nuclear facility, from any type of equipment failures to even human performance. Our work is focused on identifying any type of vulnerabilities that also could help the plant and operators to make decisions and enhance safety and also reliability. So it's basically a field where engineering, data analysis, and I would also say systems thinking all come together. And every day I feel lucky to be part of it.
That's interesting. Quite a lot of subsections coming into your role. Now, as an engineer who's worked in this sector for some time now, how do you think the role of a PRA has changed in the last few years that you've been? You did mention about decision analytics, systems thinking, and everything that's coming into picture. But to an extent, even in Westinghouse, I think the technologies are evolving. So how has your role evolved in this period, from what you actually learned to kind of what's actually happening on ground on projects?
Yeah, so I think as a PRA engineer, we are constantly trying to keep on track with everything that's currently happening. As you said, even though part of my majority of my work is related to current operating commercial nuclear power plants, we have also been learning about the SMRs, the small modular reactors, or even the microreactors, right? But the very interesting thing about PRA, Probabilistic Risk Assessment, is essentially how it is structured, right? So we are in charge of asking and obviously answering three big questions with PRA. So this is what could go wrong, how likely it is to happen, and what are the consequences if it does, right? So in the nuclear industry, whereas we're working with small modular reactors or commercial reactors, we use PRA to quantify and understand risks across the entire plant. They could be mechanical systems, electrical components, even human actions, as I previously mentioned, like everything, right? So we use real world data, simulations, and also logical models in order to estimate risk frequencies and potential outcomes, right? It's like trying to predict the future, but with data. And I would say that what makes PRA powerful is that it doesn't just stop in the design level, specifically talking about SMRs, right? But it also evolves with the plant while either it is being designed or it's already under construction or it's already operating, or even if it's under decommissioning activities, right? So as the system ages, new technologies are introduced or procedures are updated. We also have so many procedures, so many guidelines, rules to follow, right? So PRA adapts, and that is in order to ensure that helping the plant in order to remain safe under changing conditions.
That's interesting. The depth in your answer tells that you're pretty much involved. But now, stepping back again, I understand that you have a degree and you are also passionate about sustainability. How did all of this actually shape your career, and how did you get into this niche space in nuclear energy? Are there any interesting stories related to this?
Oh, 100%. Trust me, I would be talking about nuclear endlessly. So, as you correctly said, I have a bachelor's degree in sustainable development engineering. I got it at Monterrey's Technology Institute in Mexico City. And I got my degree in 2018. And ever since then, I've been very excited about the industry. Well, since I was a little child, I was like 12 years old when I read Angels and Demons, which is a novel by Dan Brown, where it mentions the CERN Institute, which is a research and development institute about nuclear technologies and science in Europe. So I started doing my research. I was so passionate about certain topics. And then I came across the nuclear energy and nuclear technologies. I started learning about it and be like, hey, this seems to be the answer to many different issues that we as a humanity share as a whole. Let's call it global warming, climate change, cancer, the problems with agriculture, I don't know, pests, like many different common issues that we all shared, regardless of where we are located around the world, right? And later on, as I just kept doing my research and reading, I realized that there are a lot of misconceptions around it. So that's basically at 12 years old when I realized I really wanted to focus my career on this. So later on, I got my degree, as I just shared, in sustainable development engineering. I learned a lot about many different sources of energy, most of them clean, like solar, wind, hydraulic. But then I started questioning myself, if I am learning about clean sources of energy, where is nuclear? And believe it or not, after 5 years trying to obtain my degree, I only got one class about nuclear energy. I was still pretty excited about the topic, and that's when I had the opportunity, along with my family, to move to the US. Another opportunity took me to the International Atomic Energy Agency. I had an internship there, which I recommend to all of your listeners if they really want to start getting involved in the nuclear energy industry, or it could be nuclear technology, nuclear energy. They should definitely look into the International Atomic Energy Agency internships opportunities. So I went there, I lived there for almost a year, and I worked hand in hand with people at the Technical Cooperation Program. they have a strong relationship with the countries that are currently pursuing this technology. And again, it could be related to producing electricity, or it could be for hospitals. It could be for cancer treatment, for pests, for agriculture, for animals. So there are many different uses, peaceful uses of nuclear technology that definitely impresses me. So when I came back to the US after a year of internship, I was very focused on looking for my dream job, right? And the nuclear energy industry is extremely, extremely big. You don't need to be a nuclear engineer like myself. I'm not a nuclear engineer to become part of the industry, right? We need communicators. We need engineers. We need electricians. We need people focused on publicists. I don't know, many different careers, financial, economics, many different
True.
things. So I saw all of the opportunities and I came across this one that was called PRA. And it was so exciting for me to see how easily they were using the word risk, right? Because for many people, when I still shared at, family meetings, hey, I'm a nuclear engineer, it's like, oh my goodness, isn't that like high risk position, or are you in danger? And it's like, no, not at all. So after continuously, working as an engineer, keeping preparing myself, because I'm always learning, I will never call myself an expert. There's always an extra step to do that. I realized there's also an opportunity to keep engaging with the public and informing or fighting everything that they are already misunderstanding about the concept of nuclear, about the concept of risk and the industry itself, right? So that's when I also decided to use my free time to build a brand called Nuclear Hazelnut, which I basically use to share my daily life as a PRA engineer and also misconceptions about nuclear.
Sure, we will definitely get to your work around nuclear hazelnut. But your journey is very interesting. And as you rightly pointed towards the end, when you speak about risk and especially putting risk and nuclear energy, there is definitely a lot of public fear. Now, as an engineer, when you look at public fear versus the engineering reality, how do you think your role helps bridge that gap?
That's a very interesting question. I would say that as for my role, one of the most frustrating and at the same time fascinating aspects of working in the nuclear is, as I was sharing with you, is how misunderstood is the concept of risk, right? So when people hear nuclear, they often think about high risk or about danger. But in reality, the nuclear industry, trust me, it sets the gold standards for safety. And when I share this with the people, I have the backup of what I do on a daily life, right? So I can say, yes, I can assure you that nuclear energy is one of the safest sources of energy because I do this and that on my daily basis, right? I work here. I go personally to the site. I walk around the site. I meet with the people doing the incredible job of operating a plant 24/7 just to provide clean energy for you and your neighborhood, right? As for what I do, I would say, or I would also like to share with the people that every risk is quantified and is mitigated. Trust me, we have a plan A, a plan B, and even a plan Z for everything that could happen in the plan. And we also have a high level of reliability and redundancy. So, for example, I'm using a pump. What happens if that pump stops working? I have another one. What happens if that other one is not working? I have another one. Like we are prepared for every type of scenario. And yeah, I can assure you it's actually one of the safest energy industry in the world. I think I have that credibility when I say I do this for living, right? I not only read about it in magazines, but I constantly interact with people working at nuclear power plants. I have the data. I quantify the data. I know how to mitigate it along with my team. So I also share with them that PRA as a whole, it helps us bring facts to the forefront and remind the public that while not technology is risk-free, nuclear, remarkably, it's very well prepared.
Well, I definitely like the confidence in your voice when you speak about this. But as you rightly said, you have the data, you have the facts. So, can you give us some comparisons between the risk in nuclear versus other industry? say, for example, risk in other power generating sectors or risk in other industries in general. I'm sure you would have some data that you can back up and probably convince a lay person in a conversation.
Yes, that's an excellent question. So I think I would like to compare it at for right now at the top of my mind with the oil and gas industry. And that is because ever since I was little, I've been involved with it because most of my parents, my cousins, my aunts, my uncles have been working in the oil and gas industry in Mexico City, right? So I was kind of familiar with how they work and how they do things and how they have guidelines, right? And I would say that the level of, let's call them rules, level of guidance, level of precision that they have, it's not as similar as in nuclear power plants. And just to tell you an example, if you Google oil and gas events, oil and gas accidents, you're going to have more than 100. If you Google nuclear accidents, you're only going to have Chernobyl, 3 Mile Island, and Fukushima. Those are the only ones that you're going to be reading about. So I think that's like point blank the perfect example on how you can compare the credibility about safety and risk between industries, right?
But Jenifer, this is exactly the point. When we look at data, this probably favors nuclear statistically. But the fear that is probably inherent in people is like the impact of a dangerous situation arising out of a nuclear project is probably high because it leaves a lasting impression on the planet, on the community. So I think probably comparing it with oil and gas or other sectors, people generally feel like, okay, that is a short term, whereas nuclear could be long term. Is the understanding correct, or is there something that you would like to clarify on this?
Yeah, certainly. I think there's a very great example that I always use when comparing, for example, the footprint that nuclear power leaves compared to, for this specific example, oil and gas, right? So for nuclear, we know specifically where the spent fuel, also known as nuclear waste, is located, right? We know every dry casket and the location of each of one of those caskets, right? And it's perfectly safe to go around them, to take pictures with them, to walk around them, like it's perfectly safe. What about the oil and gas industry waste? You just need to take a deep breath and that's it. There's a waste. They don't account for all of the emissions that they do while producing electricity using oil and gas, right? And that's the example that I certainly use, especially when I'm speaking in countries where their air pollutions are like the level of air pollutions are very high, like Mexico. And I don't know, prove me wrong. Tell me if I'm telling you lies.
Well, this is a good example that probably even I heard it for the first time, and maybe I can probably use it for if I get into a position when I have to defend nuclear at some point. But this is good. But now getting back to the big picture, when big events happen, like for example, the Fukushima or Chernobyl, there's a lot of conversation happening. So as someone who's got into the sector after those events, now, how do you think the entire landscape, you said like safety in nuclear is probably the gold standard. So how do you think the big events have actually shaped this?
Yeah, for sure. I mean, for the starters, and just as a little bit of background, Chernobyl happened due to lack in certain designs. It didn't have a containment and also political reasons, right? The extent
True.
of that event could have certainly been shorter with better decisions. And we as an industry, as a whole, we certainly learned from that, right? So now all of the nuclear reactors that you see, they have a containment. And let's not even talk about the guidelines again and the very strong rules that now are currently part of a daily basis of operating a nuclear power plant, right?
True.
But now talking about Fukushima, which is a little bit more recent, right? So Fukushima changed everything for us as talking about PRA practices, right?
Mm.
It taught us that we need to consider not just expected, but also unimaginable events. And I'm going to go a little bit deep into that afterwards.
Sure.
Before Fukushima, PRA models often stopped at single unit failures, right? But now, post Fukushima, we started modeling multi-unit and multi-hazard events like what happens when an earthquake plus a tsunami plus a power outage all happen at once, right? Using this as an example, we also enhanced how we model station blackouts. For example, when we lose outside power, because believe it or not, even when a nuclear power plant is producing power, it still needs a backup power.
True.
And what would happen also with hydrogen generation events, which are very known as being potentially hazardous and able to cause an explosion, right? These lessons weren't just academic, to put it that way. These lessons led to concrete upgrades in the plants around the world, change also in the policies, and also in global collaborations on nuclear resilience, right? To me,
True.
it is definitely an example of how the industry learns and evolves. We don't ignore our past, we integrate it, and we also build a safer future. And now, going a little bit back about what I mentioned about unimaginable events, I think I've shared a little bit on about the following on my page, but believe it or not, we not only model about potential earthquakes, potential tsunamis, potential natural events like flooding, we also modeled what would happen if a plane would just accidentally crash into the containment. Can you imagine what would happen? Do you have like any idea at the top of your mind?
Well, I think the power plant would everything go to shutdown, and would it just be safe for everyone to come? At least if they are able to come out of the airplane, would they be safe?
That's for sure. I think you had a good idea, because so often when I make this point and I ask this question, people potentially think that it would be the worst case scenario. But just to keep talking about this example, the length of the concrete from the containment is about 1.5 meter thick. So with that potential event happening, nothing would happen to the containment. We obviously would put the plant in a safe environment. Obviously, we would safely shut it down and assess the potential risk that this event would cause, but nothing would happen. No hazardous releases, no radiation releases, and our reactor could stay safe. And I have the numbers.
That's good. Now, you did mention about all the scenarios that you model, the cases that you consider, and to assess all the risk and probability. What else do you do in a typical day as a PRA engineer?
Oh, that's a great question. So, no 2 days are the same, which is something that I love. As a PRA engineer, some days I'm reviewing plant configuration changes, for example, like whether taking a pump offline to do some test or maintenance, and how would these activities will increase the risk or the overall plant risk, right? Other days, I'm analyzing event reports. What happened when there was like emergent situations where a pump went offline unexpectedly, right? Some other days, I'm answering questions from plant staff, working with them, or also working on risk-informed inspections for the NRC. There are also regular tasks like updating our PRA models, where we input new data, even which is from operating experience from the industry, from other plants, or also within our design. I'm also evaluating mitigating system performance indexes and also supporting refueling outage plannings, right? And those days are very exciting, if you ask me. And I mean, yes, there's a never ending list of acronyms. Hopefully, I'm not using a lot of them right now. But just as a funny fact, I still have printed like a cheat sheet on my desk just in case I need to read about acronyms, because for PRA engineers, it's never ending. As you can see, PRA, it's such a great example. Instead of saying Probabilistic Risk Assessment Engineer, it's PRA, right? So for the systems and for the plant and for certain studies and guidelines, we still have acronyms. So there's like a never ending list of acronyms. And I mean, above all, my day is about collaboration, right? Working with mechanical, electrical, operation teams in order to make risk-informed decisions that keep our plants running safely and smoothly.
That's good. Looking at multiple scenarios and no 2 days being the same, to having a list of acronyms on all the jargon, and in a company like Westinghouse, whose role is also evolving now with small modular reactors and other things coming into the picture, how is the emergence of new tech and the role of technology like AI, how is it all changing the landscape for professionals like you in the industry?
Oh, that's definitely a huge opportunity for us all, right? Because we're continuously learning about AI, especially the amount of energy that it needs to keep operating. And that's where nuclear comes in, right? Because of the continuous growth of this technology and also the usages of this technology, because it's not only how fun would I look as a Studios Ghibli picture, right? But it's as much as, for example, helping people doing research or reducing the time that you spend doing research, certain reading articles or gathering certain information. It certainly saves a lot of time, right? And I think there are a lot of peaceful usages of AI, but that requires cooling and that requires a lot of electricity and 24/7, because you and I are located in different part of the world right now, right? So when I am asleep, you are obviously super awake and doing all of your activities and potentially using AI. And when you're sleeping, I am awake using AI, right? So it's a 24/7 constant requirements for electricity. And how good it would be if we provide that electricity clean. And now, talking about SMRs, the incredible characteristics that they have among producing electricity 24/7 is their mobility, right? They can be transported or built at any location because they need a smallest land compared to the current operating nuclear power plants, right? So even though they provide a little bit less clean electricity than the current super big operating commercial nuclear power plants, these ones are modular. These ones can be moved from certain locations where transmission lines couldn't even exist, right? So with the small modular reactors, you could be, and now linking it to AI, with the small modular reactors, you could be providing 24/7 electricity with no breaks to AIs, to servers, AIs located in remote locations in a clean manner, right? And also in a safe manner. So I do believe that in the next coming years, we could be seeing the pilot versions of the many different and very exciting models of SMRs. And I'm looking forward to that.
A quick question on that, a follow-up question on that. So how does a PRA engineer rate risk and safety for an SMR? Easy, medium, or very tough compared to conventional reactors?
Well, I would say that since the technology is similar, we already have half of the work, right? But as I previously mentioned, we are still currently evolving. And right now, I would say that we are in a situation like the chicken and the egg, right? What comes first? The pilot version of the SMR or the PRA? But we need the PRA to have the pilot version, right? But we need the pilot version in order to have PRA. So we are constantly working together while designing these SMRs and also improving and trying to structure the PRA models that we currently have for commercial power stations into SMRs. So as I told you, we already have like 50% of the work that needs to be done, right? We have the experience, we have the people that know PRA, but now we need to accommodate it into SMRs. So I think it's a work in development. You definitely need PRA. You don't start a nuclear reactor or you don't start an SMR or even start the pilot version without PRA, right? Without accounting for the overall risk that it could be associated with the model. But it's certainly under development. I would say whether you put a new design, a new piece, a new model, we also use it on PRA. So it's just in constant development, in constant evolution, I would say.
A last question on SMRs. So You did mention it's close to 50% done. So how many years will the next 50% take? When can we actually see commercial projects from SMRs?
Oh, I would say, according to the timeline that we have been reading all along the internet, 2030 would be the closest, probably earlier.
But yeah, come on. As a person in the industry, I would expect a more close answer, even though I'm not going to hold you accountable for that. So even you think it's 2030?
I would love to think about an earlier date. I would love to say 2026 because there are already a lot of pilot models. But then stories like NuScale, and I don't know if you were familiar, but they already had the first authorized and approved model by the NRC in order to become a pilot version, right? So it was the first one. And everybody in the industry was extremely excited to, welcome that new model as the first pilot version of an SMR recently approved by the NRC. But what happened? It's not only about having the excitement of building this type of projects, right? We also depend on money. We also depend on investments. So when certain changes occur, because it's not the same of having a project in paper than starting actually that project and start building that project, right? There are a lot of financial overturns. And you could say, okay, this is my model in paper, but when I'm trying to build it, I need something more. There's something else that I didn't account it for, or I accounted for, but I need it bigger, right? So that changes the budget that you have to build that project. And that's unfortunately what happened with the NuScale project. They stopped working towards it because there were a lot of overturns in the budget. So I would love to tell everybody here listening, our upcoming SMR, it's coming in 2026, right? Oh hell, it's coming next month. But it definitely requires more decisions than the engineers and the designers that are working building the pilot version, right? So I always share that within the nuclear energy industry, everybody wants to be the second. Nobody wants to be the first, because this is what happens. In this case, NuScale was the first, and unfortunately, the project was canceled, right? Even though it had all the approvals that it needed and it had all the people and all the hands on the job that were needed, money is still a very important factor on this type of projects, right? So yeah, that's why I was saying, okay, it could be earlier, it could be later, as long as it is safe.
So NRC is the Nuclear Regulatory Commission, right?
Yes. It's the Nuclear Regulatory Commission in the United States.
Fair. Now, finally, I think you have a lot of positive things to share. And I think Nuclear Hazelnut is what you actually started to kind of share insights and all the things that you're working on. So how is it going and what plans do you have for Nuclear Hazelnut?
Oh, absolutely. So as I shared, I started like Nuclear Hazelnut in order to start like sharing nuclear facts, right? But it's definitely, it has grown into a platform for outreach. And I mainly use it to talk about safety and to bust myths and to connect with people who are curious or skeptical about nuclear energy. Social media has definitely been a powerful tool in this sense, right? And I've had conversations about waste management or the scale of land uses for renewables against nuclear energy, the potential for small modular reactors, as we just talked about. All of that has sparkled a lot of very interesting conversations. And I think I would love to just keep doing that, to keep having the opportunity and platforms like yours to just talk about the real face of the nuclear energy industry as somebody that is working on the inside, right? Because ultimately, nuclear energy isn't just about neutrons and megawatts, right? But it's about the people. It's about trust, and it's about the future that we as a society would like to build. Because when I talk about nuclear technology and nuclear power, I also like to share that the benefits of working with the peaceful uses of that technology will benefit your neighbor, will benefit the people around the world, whether you know them or not, because it helps us as a society, as a humanity. whereas you are located. And that's what I love about nuclear. It brings us together.
Fantastic. I will definitely let the listeners of Mission Junior podcast know where they can follow your work and everything that you're doing. Because definitely, as when they listen to your work, and I'm sure they'll feel like really happy because the conversation that we just had was very insightful and it clearly shows your passion and also the work that you've been doing. So, Jenifer, it's been an absolute pleasure having you on the podcast today. Thank you for again joining me on the show and sharing all your insights.
Yeah, it has been wonderful to be here and to connect with so many listeners that are engaged with this incredible podcast. Thank you so much again for having me, Girish. I appreciate that.
That was Jenifer unpacking the often misunderstood and underappreciated but absolutely critical world of probabilistic risk assessment in nuclear energy. From how PRA has evolved in response to major nuclear events to its current role in shaping safer and more resilient designs, especially in the context of small modular reactors, this episode brought clarity to the framework that quietly underpins much of nuclear safety narrative. We also explored the future of PRA, particularly how advances in AI and digital tools could reshape risk modeling and decision making in nuclear systems. These are the kinds of behind the scenes shifts that will determine not just how nuclear is perceived, but how reliably it performs in tomorrow's energy systems. So, if you have been following our nuclear series, this episode adds yet another essential perspective, one grounded in data, probability, and engineering foresight. Next, we continue the series with more voices from the cutting edge of nuclear, exploring how science, policy, and technology are coming together to shape the sector's future. With that, this is Girish Shivakumar signing off, and as always, thank you for listening to Mission Junior, Conversations towards the global zero carbon transition.